Hi everybody and welcome. Today's video we're going to be talking about the angle of depression. So after watching today's video you will be able to define in context and use to solve the angle of depression with trig problems. So the key for today is taking a look at another trigonometry skill in practice in the real world that allows us to solve for unknown quantities. So starting off, angle of depression is the word. So for the angle of depression, this is the angle formed by the line of sight and an object below this level. So if we are looking at a person that is standing and they're looking at something down on the ground, maybe a perfect little dog like Winnie, what we're going to see is if we trace their vision from their eye down to that object, so from their eye down to Winnie's eye, we'll see that that will be the object that we're looking for here. And then again, both you and the dog should be on the ground. So this angle, this time, is formed by basically what we are looking at down from your eye to whatever that object is. Now the tricky thing here is we have the ground as a line, but we also have to use the line of sight from your eye as a line as well. So angle of depression has one more calculation in it that makes life a little bit more challenging. So the angle of depression is actually here. This angle right here in that little section. So it's not the angle below that, it's the angle on top of that. So when we're looking at this, it kind of forms a situation where in some ways it's almost like an inverted triangle. It's upside down. So if we're going to use the angle of depression for this with a 90-degree triangle, what we're going to see is our option becomes a little bit limited with this because this is a triangle that we're given. Now, because that's a little bit inconvenient, actually the easiest way to deal with that is to remember that if we're going down from this line and we could form this green triangle, it's a little bit easier to work with. We just have to do a calculation to solve for that angle right there. So this corner, all the way from here over to here, that corner is still a 90-degree angle. So what we would do is we would take whatever this angle is, our angle of depression, which 23 degrees is what it's telling us. So the top here, 23 degrees. We could take that 23 and subtract it from 90, and that would give us our second angle. So 67 degrees would be the other angle right there. So that is the one trick to the angle of depression, is it's not the readily available one. Sometimes you have to subtract it from 90, and after subtracting it from 90, that can give us sometimes a more useful angle for what they're actually asking for in the question. So the key for this one, as always, draw a detailed diagram, label all of your parts, and as long as you're doing that, you're going to be in really good shape to solve these questions successfully. So we'll go over an example from here, and we can take a look at what we have. So Mr. Reardon flies to Massachusetts in an airplane, and it passes over DACC. From his airplane at an altitude of 1,200 meters, the angle of depression to DACC measures 28 degrees. Find the distance from Mr. Reardon to DACC. So, taking a look, another beautiful drawing coming your way. If you ever want autographs for these, just let me know. I'm happy to sign your notes papers. It'll be worth something someday. So there is Mr. Reardon. And then let's draw DACC here. I know that it seems kind of silly to do something like this, but honestly, the more detailed your drawing is, the more it's going to make sense. And actually, I was a little bit hasty drawing that. We should measure out our angle first from the airplane. So 23 degrees from the airplane is what we're looking at here. So that's our 23 degree, angle line. So drawing this all the way down to the ground is what's going to give us DACC. So now we can place DACC on the ground, and we'll put a nice 0-degree flat ground here underneath our airplane. So drawing this in. So remembering that our angle of depression goes right here, angle of depression AOD, and we measure that this was 28 degrees. So 28-degree angle right here. There we go. And again, seeing, double check. I might have put the wrong thing here. I think I put 23, but let's just pretend that that's 28 degrees and it'll all be okay. We'll shift it. We'll shift DACC just a touch. But let's see, we'll fix it, we'll make this good. Okay, so 28 degrees moves DACC just a little bit. Not a big deal, quick fix. Thanks to the magic of the iPad. There we go. Okay, so 28-degree angle of depression right there. And what we are trying to measure is the distance from Mr. Reardon to DACC. So if I'm in the airplane, we're going to see that the distance from me to the airplane is this green line right here. It's going to be our hypotenuse. So we have a couple of options for solving this. If we want to use our triangle that is touching the ground with that as our 90-degree angle, we would have to do 90 minus 28, punch that into our calculator, and that should give us 62 as our measure. So we could have 62 as our angle here. We know that this is a 90-degree angle right here, and that would allow us to solve for some of our options here. Again, does not make a difference which way that we want to solve. We have the choice as to the top or the bottom triangle that we want to use. Second thing in the question, it tells us the altitude is 1,200. So the plane is 1,200 meters off the ground. So again, 1,200 meters off the ground. Doesn't matter which way we use. I think sometimes for simplicity's sake, it can be easier to be consistent and to use the bottom triangle. But if you are somebody that likes to use a top triangle, not a big deal. It doesn't make a difference for us either way. As long as we are solving for x, we're solving for the hypotenuse across from our 90-degree angle. So once again, setting up SOHCAHTOA, our trigonometry functions. If we're using this 62-degree angle as our measure, we're going to see that 1200 is right next to that 60-degree angle, so that's going to make it our adjacent side by definition. So adjacent means directly next to, so 1200 directly next to 62 degrees. So we have adjacent, we have hypotenuse. So hypotenuse and adjacent, when we put those two things together, we are looking at the cosine function. So in this situation, our adjacent is 1200, hypotenuse is x, and our angle is 62 degrees. So again, put cosine over 1 and cross multiply using our red and blues. So blue this time is going to be x times the cosine of 62. Remember, it's not 62, it's the cosine of 62. So cosine and 62 are married. They stay together here. Then in red, 1200 times 1 is just 1200. And we have to finish by solving for x. So treat cosine of 62 like a quantity. Do not punch that into your calculator yet. We do not want to do that. It's going to lead to rounding. We don't like rounding. We're going to divide both sides by the cosine of 62. So we'll simplify to 1 over here, just leaving us with x on the left side. And then on the right side, we can punch in 1200 divided by the cosine of 62. So 1200 divided by the cosine of 62. Always check in your settings that you are in degrees there. So again, if you're in radians, change that over to degrees. And then we can punch in our value. So once more, it was 1200 divided by the cosine of 62. So 2556.07. And we're in meters. So So what we're going to see is, again, this distance right here, 2566.07 meters. That's going to tell us how far away we are directly from the front of the airplane to the base of the ground right on the corner of the DACC building. So again, interpreting this in context, keeping your units as meters, solving correctly using the correct function here, which is cosine, and we have everything solved for. So once again, can't emphasize this enough. Each of these questions we need to be drawing diagrams for. We need to actually have the things that we're solving for present. We need to use our trigonometry definitions and have everything written out. So thanks for watching as always. Make sure you use those diagrams when you solve. Let us know if you have any questions, and you